محمد وعلى آله وصحبه أجمعين. This is section 3.2, measures of variation. We studied measures of center in section 3.1, center and location, and here we study measures of variation. For two data values, they could have the same center, the same mean, okay? The mean of quiz 1 could be equal to the mean of quiz 2, for example. But to get a good or a better vision of the data, you need to talk about the variation. What about the variation? Variation means the numbers are not the same. The numbers are not the same, different. So for example, there is a variation in quiz 1 because some few got 70, others 80, others 90. So there is a variation, okay? So there will be a variation if the numbers are different. We need a measure. We need some measures of this variation because that quiz 1 could differ in variability than quiz 2. So by measuring the center and the variation, you get a nice picture of the data. We will study in this section, inshallah, 3 measures of variation: range and interquartile range, okay? This is the range, and variance. We will talk about population variance and sample variance, and the standard deviation, which is the square root of the variance. We will talk about population standard deviation and the sample standard deviation. And in the next section, we will talk about coefficient of variation. So first, the variation. A set of data exhibits variation. There will be variation in the data if all the data are not the same values. Okay, if you have different values, then you will have variation. Okay, how to measure the variation? The easiest and the simplest measure of variation is the range. You find the maximum minus the minimum. So the maximum value in the range minus the minimum value in the range will give you an idea about variability. Okay, if you know that the maximum in the quiz is 100, the minimum is 60, so you know that the range of the data is between 100 and 60. You get some idea about the data and the variability. But we use only 2 values, the maximum and the minimum. What about the other values? Okay, what if these 2 values are extreme values? So the maximum is extreme. So in the quiz, one of the students got 100, and the other there is another one who got 0. So if we find the range, it would be 100 minus 0. So the range is 100. But maybe if you look inside the other values, all the other values could be around 60, for example. So the minimum is 50, the maximum is 70 if you do not pay attention to the 100 and the 0. So you can say that the range is sensitive to extremes because it takes 2 values only in account. So the range is a measure of variation that's computed by finding the difference between the maximum and minimum values in the data set. While the interquartile range, if you remember, it's Q3 minus Q1, the third quartile minus the first quartile. We eliminate 25% of the data to the right of Q3. So these are the high values. And we eliminate 25% to the left of Q1, the low values. So when you eliminate these high and low observations, you eliminate the outliers, okay? You get rid of the outlier problem. Okay, the interquartile range is a measure of variation, and it's determined by computing the difference between the third and first quartiles. So Q3 minus Q1. And remember, to evaluate or to calculate the interquartile range, you must sort the data first. So for example, here, this is a box plot without the lower limit and the upper limit. This is the X minimum, the smallest number in the data, 12. This is the X maximum. The largest number in the data is 70. So if I want to find the range, it's the maximum minus the minimum. So it's 17 minus 12. So the range of this data is 58. Now, also from the box plot, you see that Q1 is 30, Q3 is 57. So if you subtract 57 minus 30, you get 27. So the interquartile range, or IQR, is equal to 27. Now, the second measure is the variance, okay? Variance. We will talk about population variance and sample variance. So it's a measure of variation that incorporates all the values in the data set. All the values would be taken into consideration. What is the definition of variance? The population variance is the average of the squared distances of the data values from the mean. So x minus mu, this is the distance between the value and the mean. To find the average, we need the squared distances. So we will raise this to the power 2, and then to find the average, we find the sum over the sample, the population size, which is capital N. So this is the definition of the population variance, and we will call it sigma squared. So it will be given the symbol sigma. So population variance is sigma squared, and it is summation x minus mu to the power 2 over capital N, the population size, where mu is the population mean. Remember something from 3.1. If you find x minus mu, summation x minus mu, if you remember well, we said that this will give you always 0. And that's why we cannot use it here. So we have, because some of these distances are positive, some values are to the right of the mean, other values are to the left of the mean. So some of the distances are positive, other distances are negative. When you add all of them, you get 0. So to change the negative distances to positive distances, we square it, okay? We square this distance. So all of the squared distances would be positive. We add all of them, we divide by capital N, and we get the population variance. The standard deviation is the positive square root of the variance. So the population standard deviation would be sigma. Let me give you an example to show how to calculate the variance, the population variance. If these are the values in the population, so you have 5 values in the population. So capital N is 5. Capital N is 5. You have only 5 values in the population in this case, okay? You need to find the distance between these values and the mu. You need to calculate mu first. Mu is 25. Mu would be the sum of xi, summation xi over 5. So it would be 25. Xi minus mu, you find the difference between 15 and 25. 15 minus 25, 25 minus 25, 35 minus 25. These are the differences, the distances. You are taking all the values into consideration. You are finding the distance between all the values and mu. Now remember, if you add these distances, you will always get 0. So we need to change this negative to positive. So we raise it to the power 2. We square it. So negative 10 will be 100. There are no negative signs here. And you can add summation. You can get summation xi minus mu all square 250. You can divide 250 by 5, and you get the population variance. So the population variance of this data is 50. There is another shortcut or another formula. They call it computational formula, because we usually use this formula, not the previous one. This is somehow easier. All what you need to have is summation x and summation x squared. So if you add these values, you already have summation x because you evaluated mu. So you need, if you want to find, let us have this as an exercise. If mu is 25, and you have 5 observations, how to find summation x? Well, we know that mu is summation x over capital N. If you cross multiply, you get that summation x is mu times capital N. So in fact, summation x here would be 125. So you have summation x. You can find summation x squared. How can you find summation x squared? It is 15 squared plus 25 squared plus up to 30 squared. You will have summation x squared. So now you have summation x squared and you have summation x. You can put it in this formula, summation x squared minus summation x all squared over capital N all over capital N, which is 5 in this example, and you will get the same answer as here. You will get also 50. Actually, if you expand x minus mu square, you can prove that you will have this formula. So therefore, the two formulas are the same, okay? But here, you don't have to evaluate the mean, and you don't have to find the distances or the square of distances. You need only summation x and summation x squared. The population standard deviation would be sigma, the positive square root of sigma square, and it will have the same units of measure of the data. Okay, remember the data here were 15, 25. When you squared them, you are not using the units of measure of the data anymore. Okay, so if you take the square root of the variance, then you get the standard deviation, which has the same units as the original data. It is the most commonly used measure of variation. The standard deviation is the most commonly used. So in the calculator, you see the standard deviation, okay? The variance is not there. But of course, if you have the standard deviation and you need to find the variance, you raise it to the power 2. The positive square root of the variance is the standard deviation. Now, what about the sample variance? We talked about the population variance. What about the sample variance? The sample variance, we will call it S square. So the symbol is S square for the variance. And it is the same definition, but we will divide by small n minus 1. Okay, small n is the sample size. And this minus 1 is important because of the inferential statistic. In inferential statistic, we use statistic to predict parameter. The sample variance S square is a statistic. The population variance sigma square is a parameter. So in inferential statistic, we use S square to predict sigma square. You will get a better prediction if you divide here by small n minus 1. That's why they use small n minus 1. While the shortcut or the computational formula is also the same, but in the denominator, in this denominator, the main denominator, we divide by small n minus 1, but here by small n. We divide by small n. Remember that x bar is the sample mean. The sample standard deviation would be the square root of S square, which is S. We will use the standard deviation as a measure of distance from the mean. So we will say that your score, for example, in quiz 1 is 1 standard deviation to the right of the mean, or negative 1.2 standard deviations to the left of the mean. So we will use it as a measure of distance from the mean, and it will be clear, inshallah, in the next section. This is the end, and we can solve some exercises. I'll start by 325, and I will use the calculator here. I'll teach you how to use the calculator to find the variance and the standard deviation. To compute the range, it is the maximum minus the minimum. So it is 8. Okay, 8 minus 0 is 8. Now to compute the variance for this sample data, these samples, so he said that it is a sample. So we will use the symbol of the sample, which is S square. And we know that S square by definition is summation x square minus summation x all square over n all over n minus 1. Okay, so we can use the calculator to evaluate s square quickly, and we can also find summation x square and summation x from the calculator. So we can use the formula and the calculator together. Okay, and he can ask me a question in which I cannot use the calculator. Okay, he can say to me, if summation x is 10, summation x square is 100, for example, find the variance, find the sample variance. So in this case, you cannot use the calculator, you have to use the formula. So please pay attention that you need to memorize the formula. To use the calculator, you go to mode and choose statistic or stat. And then you press number 1, which is VAR. And now you know what VAR means. It means variance. So press 1 and put the numbers, all the numbers. So 3, you put equal, 5 equals. Equals here works like enter in the computer. So please use the calculator with me if you like. Put all the numbers inside the calculator, mode 3, 5, 3, 4, 2, 3, 0. And when you put all the numbers, okay, you can check that you have 24 numbers. You put already 24 numbers. This is the n, the small n is 24 numbers. We have 3 times 8, 24 numbers. You press on now. You press on, and don't worry, it will give you empty screen, but everything is in the memory, inside the memory. Now you have to go to stat. You have stat in orange above number 1. So if you press shift 1, okay, and then you go to VAR, variance, which is number 4. You have number 3, sigma. You use it if you want to find the population standard deviation. And you have number 4, SX, which is sample standard deviation. So I can use, how can I find S square? The calculator gives you S of X, okay, the sample standard deviation. So press number 4, say equal. The sample standard deviation is 1.998, continues. If you square it to the power, if you raise it to the power 2, you will get the variance, the sample variance, which is 3.99. Or you can, if you want to use the formula, you can go to shift stat, and now you don't press 4, which is variance, you press 3, which is sum, and you find first thing is summation x square. So if you press 1, you get summation x square. So summation x square from the calculator will be 232. And summation x, you go to shift stat, sum, and then you choose number 2 now, which is summation x 58. So he can bring a question in the exam. He says to you, if summation x is 58, summation x squared is 232, find the sample variance. So how to solve this question? Now you cannot use the calculator, you have to use the formula. So summation x squared is 232, summation x is 58, you need to raise it to the power 2, divide by n, which is 24 numbers. We have 24. Of course, he has to give you n in this case. N is 24, and we divide by 24 minus 1, which is 23. If you use your calculator to evaluate this, you will get the same answer, which is 3.99. Now, how to compute the standard deviation for this sample data? Standard deviation is called S, and it is the square root of the variance, 3.99. We already got it from the calculator, which is 1.988. So that's the standard deviation. Let us use the formula okay, we used the calculator in 325. Let us in 326 use the formula. Compute the range. The range is the maximum minus the minimum, which is 5. Compute the variance and the standard deviation. Okay, I will use this formula. Of course, he said it's a population. Okay, the variance would be sigma square, and the formula is summation x square minus summation x all square over capital N or all over capital N. Remember, there is no n minus 1 when we deal with the population. How to find summation x and summation x square? Well, that's easy. You can add all the numbers by the calculator and get summation x. So if you add all the numbers, you get 35. So summation x is 35. And you can find summation x square by finding 4 square plus up to 7 square, and you will get the number 223. So the population variance would be 223 minus 35 square over n. I have 6 numbers, so over 6 all over 6. And I can use the calculator. 223 minus 35 squared over 6. The answer is 18.83. I divide this by 6. I get the variance, the population variance, which is 3.14. So to find the population standard deviation, it is the square root of 314, which would be 1.77. Now in part C, he says, assuming that these data represent a sample rather than a population, compute the variance and the standard deviation. So I need to find S square in this case, not sigma square. Well, the only difference, we divide by n minus 1 in the denominator. So I still have 223 as summation x square, 35 as summation x, 6 as the number of the data, but here I divide by 5. So actually, I'll have 18.83, the same number in the denominator, but I will divide this number by 5 instead of 6. So you will notice that this variance, the sample variance, would be larger than the population variance because we divide by 5, not by 6. This is the population, the sample. This is the population. This is the sample variance, and to find the sample standard deviation, it is S. We need to find square root of this number, and it would be 1.94. So it's square root of 377, which is 1.94. Discuss the difference. The difference, the S is greater than, you can notice that S is greater than sigma, or you can write it in words. You say that the sample standard deviation is greater than the population standard deviation. I leave 331 for you to answer part B, which is you indicate the data set is population or sample, and you calculate the standard deviation. Of course, you will understand from here. He says the set of data are the ages of people who attended a 5-day seminar. So these are the ages of all people who attended the seminar. So it is in fact a population. Okay, so you need, this is a population, and you need to find sigma, which is the standard deviation. You find the variance first, and then you find sigma, the standard deviation. Let me solve the interquartile range for you. So it is, we remind ourselves by section 3.1. The range is the maximum minus the minimum. I leave this for you. What about the interquartile range? To compute the interquartile range, I need to sort the data first. So 21 is the smallest. I then have 26, 27, 28, 29. I also have 34 and 38. I then have 45, 48, and 53. If I put the positions 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I have 9 numbers. Do we? Yeah, 2 times 5 is 10. That's good. I need to find Q1. To find Q1, you need the index. It's the 25th percentile. You multiply times 10, you get 2.5. It's not an integer, so you round it up to 3, and then Q1 would be the number in the third position, which is 27. For Q3, the index is 75 over 100, 75th percentile times 10. This would be 7.5. It's not an integer. You round it up to 8, and Q3 will be the number in the 8th position, which is 45. Of course, the median here would be in the center, would be between 29 and 34, and these would be the 3 quartiles. The interquartile range is by definition Q3 minus Q1, so it's 45 minus 27, and this will give you 18. This is the end of this section. I stop here and I open the floor for questions. Please, if you have any question,